everyone. We're going to review the part 2 of our rationals unit, which consists of solving rational equations and then graphing, or specifically analyzing some rational equations graphs. We're not going to have to draw the picture, but you need to be able to tell me where everything is going to happen. And we'll use Desmos to verify it, but you need to be able to algebraically tell me where things are going to happen. So we'll start off with solving. For this crash course, you'll notice that each type of problem has an example and a practice. I'm going to leave the practice for you. The key to this is on Schoology. If you want to see it worked out, you can look there. But I'm going to do the examples with you, and then I'll leave the practice for you guys to do. So for the proportion problems, you can think of this two ways. You can think of this as cross-multiplying. So you multiply 5 times x plus 1 and 3 times x minus 2. Or you can use the strategy that we've been using, which is get a common denominator and then ignore the denominator. I'll show you how they end up being the exact same thing. Okay, if you multiply the denominators times each other and then you were to clear the fraction by multiplying by the least common denominator, these go away and look what you got. 3 times x minus 2 and 5 times x plus 1. So it's the same thing in the end of the day. It doesn't matter how you think about it. But once you get to here, you just have to distribute 5x plus 5. On the right side, I have 3x minus 6. And now it's a multi-step equation. Get all your x's on one side. I always move the smaller amount. 3 is smaller than 5. Get everything else on the other side. So subtract 5. 2x equals negative 11. And then lastly, you divide by 2. So the answer is negative 11 over 2. Now, these problems all have what are called extraneous solutions, or could potentially have extraneous solutions. So you need to go back and say, hey, if I plug that in, do I get 0 in the denominator? And I'm looking here, I'm like, well, if it were negative 1, that would give me 0. Or if it were positive 2, that would give me 0. This is neither of those, so we're okay. But if I would have gotten negative 1, I'd be like, no, that's extraneous. You can't plug in negative 1. Or 2, you can't plug in 2. But you can plug in negative 11 halves. So that's fine. We're good. Now, let's do one that's got a monomial, a single term in the denominator. So you look, you're like 2x squared, and 2x. This guy needs a 2. And if you do it in the bottom, you have to do it in the top. This guy needs an x. And if you do it in the bottom, you have to do it in the top. Now, everything is over 2x squared. So ignore the denominator and just look at the top. In the top, I have a 5 plus, distribute, 2x plus 2 equals, on the right side, 3x. I'm going to combine like terms. 5 and 2 makes 7. And last thing, get all your x's on one side, minus 2x, and you get 7 equals x, and that is your answer. So again, you got to look to see if there are any extraneous solutions, and the extraneous solutions would be if you just plugged in 0, then the whole thing would be 0. All of them are actually the same. So since it's not 0, we're good. That works. This is where it starts to get a little tougher. We have binomials. That means there's 2 terms in the denominator. Let's say minus 9. I'm going to give myself some room to work because I'm going to have to do something here with all these denominators. You see that this has x plus 8 and this has x plus 8. Well, this guy needs an x plus 8 in the denominator, so I will do that in the top and the bottom. Now everything is over that denominator, so we're going to just focus on the numerator right here. So in the top, I have an 8 minus 9x minus 8 times 9 is 72 equals negative x. And I'm going to combine some like terms. Let's see. I got 8 minus 9x minus, so 8 minus 72, that's negative 64. And then I'll get all my x's on one side. Negative 64 equals 8x. And then last thing I'll do, divide both sides by 8. Oops. Oh, that's not working. What's going on? Why is it thicker? Oh, I don't know what happened. Divide by 8. Divide by 8. And you get x equals negative 8. Or does it? If you go back up top here and you plug in negative 8, you get a 0 in the denominator, which means this is an extraneous solution. There is no solution to this problem. The only solution that we found is considered extraneous. So be careful because that can happen. So a little fancier there in that problem, but nothing too terrible. Let's do one now where we have to factor. I'm going to give myself some room to work again. Now, if you see that you can factor something, like I could factor out an x, then do that because that helps you see the common denominator. This already has an x plus 3. This has an x plus 3, but this guy needs an x. And this guy needs both x and x plus 3. Now that everything is over that denominator, I'm just looking at the top. X times x is x squared. 2x times x is 2x squared. 2x times 3 is 6x, and on the right side I have 9. So when I combine like terms, 3x squared plus 6x, I'm going to move this 9 over in one step, so I'm also subtracting 9. I know it needs to equal 0, so I'm going to just move that over right now. Okay. Now when you factor, it's nice to do common denominator because then it makes the problem a little bit easier. So I'm going to factor out a 3 here. And now, since it's 1x squared, this is easily factorable. The numbers that multiply to negative 3 and add to 2 are positive 3 and negative 1, which means my zeros are negative 3 or positive 1. Or are they? Can I plug negative 3 and positive 1 in? If I plug negative 3 in right there, oh no, that's extraneous. You can't do that. You get 0 in the denominator. Don't do that. Can you plug 1 in? 1's fine. 1 squared plus 3. Yeah, that's fine. That one works. 1 works. Cool. Okay. So look for extraneous solutions. You can't divide by 0. That's where these come from. That's solving. Now let's get graphing. So one thing I might ask you to do is if I give you a graph, can you just tell me what I'm talking about? Like vertical asymptote is right there. The equation of that line, it's at 2, so we say x equals 2. And horizontal asymptote's right there. That's y equals 1. You can see the x-intercept is right here. That's at 1, 0. And you can see the y-intercept is right there. I'm guessing, I'm just going to guess. I can't know for sure where that is, but I'm just going to say it's about 1/2. Again, I don't know for sure. Unless I know the function, I can't tell you for sure. But I'm just going to guess it's about at 1/2. So how do we do these things algebraically? If I give you a function, how do you find the x-intercept? The first thing you're going to do is set the top of the fraction equal to 0. Set the numerator equal to 0. Okay, if you're trying to find x-intercepts, you set the top equal to 0. If you're trying to find vertical asymptotes, you set the bottom equal to 0. So for this part, right below it, you set the denominator equal to 0, and then you solve for x. Okay, so every problem, set the top equal to 0, set the bottom equal to 0, solve. Sometimes you have to factor, sometimes you can eyeball it. To find the y-intercept, plug in x equals 0, and then solve. Whatever you get, that will be the y-intercept. All y-intercepts have the same x value. They're on the y-axis, so it's always 0. The last thing is tricky, and this depends on the degree. So I'm going to make an example of each one of these. It says, if it is, the numerator has a higher degree than the denominator, so something like this, x cubed over x squared, I call that top heavy. If it's top heavy, then there actually isn't a horizontal asymptote. So we'll say there is none. Come on, none. But there is a slant asymptote. And to find the slant asymptote, you use long division. If you'd like to see that, I have an extension for you. If you're going to pre-calc next year, we will do that in pre-calc next year. What if they're the same? So if it were like x squared over x squared, I'm going to make it like 2x squared. If they have the same degree, then you divide the leading coefficient. So in this example that I have right here, 2 divided by 1 would be 2. So this example, I would say y equals 2. Because you divide the leading coefficients. 2 divided by 1 is 2. And the last one, if it's bottom heavy, like x over x squared, so the numerator is x to the first and the denominator is x squared, then the asymptote will just be at y equals 0. It will be the x-axis. Okay? So you need to remember that process and you need to be able to solve those things. But when I give you a function, you kind of have to go through those steps. So let me do one with you here. This says, okay, first I'll set the top equal to 0. X squared minus 3 equals 0. You don't need to factor this. You can just solve by square roots. And remember, if you square root, you got to put plus or minus. So the x-intercepts are radical 3 and negative radical 3, 0. As a decimal, that's about 1.7, I think it's like 1.73. Vertical asymptotes, you set the denominator equal to 0. X minus 1 equals 0 when x equals 1. So that's the vertical asymptote. The y-intercept, you plug in 0. If you plug in 0, those go away. Negative divided by negative is positive. 3 over 1 is 3. And the last thing, this has a degree 2, so that's x squared, and in the denominator is degree 1. So this is top heavy, which means There is no horizontal asymptote, it's a slant asymptote. And when you look at it, and this is what I want you guys to do for your homework and things, is graph it and make sure you did this right. So if I look at it, you see that the y-intercept is supposed to be at negative or positive 3. It is. The x-intercepts, I told you it was like 1.73. Look, I nailed it. 1.73, 1.73. And then there is no horizontal asymptote. It's a slant asymptote, but there is a vertical asymptote right there at x equals 1. So all of the things that I said should be there are, and you should verify it in the graph to make sure that they are. Like I said, do the practice problems, check the key to make sure you're getting those right, do the study guide. If you can do those things in your homework, guys, 100% no problem on the test. So do those things and make sure you smash that like and subscribe.